Hello everyone, I am Manan and I am going to read the chapter Metals and Non-Metals. We are already aware of certain metals like iron, aluminium and copper as we use them in our daily life. We get metals from the earth's crust and from the oceans. Metals were discovered thousands of years ago. Progress the progress of mankind is linked to the discovery of different metals. For example, we talk of the Copper Age, discovery of copper, and the Iron Age, discovery of iron. Elements are divided into three types: metals, example iron, copper, and aluminium; non-metals, example carbon, oxygen, hydrogen; metalloids, example silicon, germanium. Metalloids show the properties of both metals and nonmetals. Nonmetals were discovered much later. Nonmetals occur both in free state and in the form of compounds. Before we go forward, let us understand what are the elements. What a substance which cannot be broken down into simpler substances is called an element. Iron, copper, oxygen, hydrogen, carbon are all examples of elements. There are 118 known elements. These have been divided into three main groups depending upon their properties: metals, nonmetals, and metalloids. In this chapter, we will study about commonly used metals and nonmetals, their physical and chemical properties, and their uses in our daily lives. We will study about the metalloids in higher classes. Physical properties of metals and nonmetals. Both metals and nonmetals are used extensively in our daily lives due to the specific properties. All metals have some similar physical properties. The physical properties of nonmetals are opposite to those of metals. It is important to understand the meaning of these physical properties. Luster. It means the material has a shine, reflects light. Example: silver, gold, and copper. Malleability. It means a material can be beaten into thin sheets without breaking. Example: a blacksmith beats an iron piece to make a spade, shovel, or an axe. Ductility. It means a material can be stretched or drawn to form thin wires. Example: copper can be drawn into copper wires. Sonority. It means a material makes a ringing sound when struck hard. Example: iron. If we drop an iron plate, we hear a ringing sound. Electrical conductivity. It means a material can conduct electricity. Example: copper. Thermal conductivity. It means a material can conduct heat. Example: iron. Based on the physical properties, metals and nonmetals can be distinguished as follows. Physical properties. Luster. Metals lustrous, nonmetals dull. Physical properties. Malleability. Metals malleable, can be beaten into thin sheets. Nonmetals non-malleable, cannot be beaten into thin sheets. Physical properties. Ductility. Metals ductile, can be drawn into thin wires. Non-metals non-ductile, cannot be drawn into thin wires. Physical properties. Sonority. Metals sonorous, produce a ringing sound when struck hard. Non-metals non-sonorous, do not produce any ringing sound when struck. Electrical conductivity. Metals good conductors of electricity. Non-metals poor conductors of electricity. Thermal conductivity. Metals good conductors of heat. Non-metals poor conductors of heat. Hardness. Metals hard and strong, do not break easily except sodium and potassium. Non-metals soft and not strong, break easily. Metals. From the physical properties, we can say the materials that are lustrous, hard, malleable, ductile sonars, and good conductors of heat and electricity are called metals. Examples of metals: iron, copper, aluminium, calcium, magnesium, zinc, silver, gold, tin, lead, tungsten, chromium, sodium, potassium, and mercury, etc. There are certain metals that do not possess the above properties but are placed in metals. Examples of these exceptions are sodium, potassium, and mercury metals. Sodium and potassium are soft and can be broken or cut with a knife. Mercury. It is a liquid metal. It is the only metal which is found in liquid state at room temperature. Non-metals. Materials that are dull, soft, non-malleable, non-sonorous, and poor conductors of heat and electricity are called metals. Examples of non-metals: copper, sulfur, phosphorus, hydrogen, oxygen, nitrogen, chlorine, iodine, helium, etc. Iodine is an exception as it is the only non-metal that is lustrous. Activity 1. To study electrical conductivity in metals. So set up an electrical circuit as shown in figure 4.1 with two metal clips. Check the circuit by touching the metal clips together. Bulb should glow. Test the connectivity of following materials by holding them in between the clips. Material: iron wire, glowing of bulb, yes. Sulfur, no. Coal piece, no. Copper wire, yes. Aluminium foil, yes. Zinc wire, yes. You will observe that the bulb glows in all metallic wires as metals are good conductors of electricity. Chemical properties of metals and nonmetals. Metals have common chemical properties. It means that when metals react with a substance, they undergo similar chemical reaction. However, their reactivity can differ. Some metals are more reactive than others. Metals such as sodium and potassium are extremely reactive. They react with oxygen at room temperature and catch fire. Most nonmetals are non-reactive. Let us study the reaction of metals and nonmetals with certain substances. 1. Reaction with oxygen. 2. Reaction with water. 3. Reaction with acids. 4. Reaction with bases. And 5. Reaction with salts. First, reaction with oxygen. Metals react with oxygen to form metal oxides. Metal oxides are basic in nature. Different metals react with oxygen under different conditions. Some metals react at room temperature while others react on heating. Metal plus oxygen from air gives us metal oxide, basic oxide. Iron reacts with damp air, oxygen and water to form iron oxide called rust. Iron, Fe, which is a metal, reacts with oxygen plus water from damp air gives us iron or rust, Fe2O3. Magnesium burns in air to form magnesium oxide. Magnesium, Mg, which is a metal, reacts with oxygen O2 to form magnesium oxide 2MgO. Corrosion of copper. When copper vessel is exposed to damp air for long, it acquires a dull green coating, which is a mixture of copper hydroxide and copper carbonate. The formation of green coating on copper objects is called corrosion of copper. Copper, Cu plus CO2 plus hydrogen plus oxygen from damp air gives us copper hydroxide, CuOH2 green coating plus copper carbonate, CuCO3. Activity 2. To check the nature of metal oxide like rust. Take a spoonful of powdered rust, iron oxide. Dissolve the rust in little water. This is rust suspension in water. Test the rust suspension with blue and red litmus paper. Red litmus paper turns blue. Since red litmus paper turns blue with iron oxide, it shows that iron oxide is basic in nature. Nonmetals react with oxygen to form nonmetal oxides. Nonmetal oxides are acidic in nature. Nonmetal plus oxygen gives us Non-metal oxide, acidic oxide. For example, sulfur burns in air to form sulfur dioxide, which is an acidic in nature. Sulfur, S, non-metal, reacts with oxygen, O2, to give us sulfur dioxide, SO2, acidic oxide. To check activity 3, to check the nature of non-metal oxides, to be demonstrated by teacher. Take a small amount of powdered sulfur in a deflating pool, a long-handled pool with a cover, and heat it over the flame. As soon as sulfur starts burning, move the spoon to a glass tumbler and cover it with a lid. This is to ensure that the gas produced does not escape. Sulfur burns in the air of the glass tumbler to form sulfur dioxide gas. Remove the spoon after some time. Add a small quantity of water into the tumbler and quickly replace the lid. Shake the tumbler well. Now it contains a solution of sulfur dioxide gas. Test the solution with both red and blue litmus paper. You will observe that the blue litmus paper turns red, confirming that the sulfur dioxide is acidic in nature. Car- Carbon is a non-metal which reacts with oxygen to form carbon dioxide, CO2, which is an acidic oxide. When CO2 is dissolved in water, it forms carbonic acid, confirming that non-metal oxides are acidic in nature. The nature of oxide formed as a result of reaction with oxygen can help us identify if a given element is a metal or non-metal. Oxide turns red litmus blue. Basic oxide element is a non-metal. Oxide turns blue litmus red. Acidic oxide element is a non-metal. Second, reaction with water. Generally, metals react with water, but non-metals do not react with water. Non-metals may be very reactive with air, and so they are stored in water. Metals react with water to form water hydroxide and hydrogen gas. Metal plus water gives us metal hydroxide plus hydrogen gas. Different metals react with water at different temperatures. Some metals react with water, warm water, some with not water, and some with water at room temperature. Reaction of sodium metal with water. Sodium metal is very reactive. It reacts with water at room temperature and produces a large amount of heat. This is the reason why sodium metal is usually stored in kerosene oil. Sodium Na metal plus water H2O gives us sodium hydroxide NaOH basic oxide plus hydrogen gas H2. Activity 4. To observe the reaction of sodium metal with water. Cut a small piece of sodium metal, dry it with filter paper and wrap it in a small piece of cotton. Put this into the beaker containing water. You will hear the hissing sound and see bubbles of gas. Touch the beaker and you will feel that the beaker has become hot. Test the solution in the beaker with a red litmus paper and a blue litmus paper. You will observe that red litmus paper turns blue, meaning that the solution is basic in nature. The above activity that shows that sodium is a highly reactive metal. However, not all metals react vigorously with water. For example, iron reacts slowly with water to form rust. Non-metals do not react with water. Usually, non-metals do not react with water. In fact, some non-metals are very reactive in air and are stored in water. For example, phosphorus is a highly reactive non-metal. When exposed to air, it reacts with oxygen and catches fire. To prevent this, phosphorus is always stored in water. Reaction with acids. Most metals react with dilute acid to form metal salts and hydrogen gas. Metal plus dilute acid gives us metal salt plus hydrogen gas. Different metals react with dilute acids differently, depending upon their chemical reactivity. Some metals react violently while some react upon heating And some less reactive metals do not react at all with dilute acids. Magnesium reacts with hydraulic acid to form an salt and hydrogen gas. Magnesium Mg metal plus dilute hydrochloric acid HCl dilute acid gives us magnesium chloride MgCl2 metal salt plus hydrogen gas H2. Similarly, more reactive metals like aluminium, iron, and zinc react with dilute hydrochloric acids to form metal chlorides and hydrogen gas. The hydrogen gas produced burns with a pop sound when lighted with a matchstick. Copper does not react with dilute hydrochloric acid but reacts with sulfuric acid. Metals like silver and gold do not react with dilute acids. Why are citrus fruit, juices, curd, chutney, and pickles not stored in metal containers? These foodstuffs contain acids. If they are stored in iron, aluminium, or copper containers, the acids present in the foodstuff will react with the metal container slowly to produce toxic salts. These toxic salts can badly affect our health. Reaction with bases. Some metals react with bases to form salt and hydrogen gas. Metal plus base gives us salt plus hydrogen gas. When aluminium is heated with sodium hydroxide base, sodium aluminate salt is produced along with hydrogen gas, which burns with a pop sound. Aluminium Al metal plus sodium hydroxide base NaOH gives us sodium aluminate salt NaAlO2 plus hydrogen gas H2. Activity 6. Reaction of aluminium metal with sodium hydroxide base. To demonstrate by, to be demonstrated by teacher. Sodium hydroxide pellet should be handled with a plastic spatula. Mix 3 to 4 pellets of sodium hydroxide in 5 ml of water to prepare a fresh solution. Drop a piece of aluminum foil in sodium hydroxide solution and heat the tube over a burner. Bring a burning matchstick to the mouth of the test tube. You will hear a pop sound confirming that it is hydrogen gas. Conclusion. Aluminium metal reacts with sodium hydroxide base to produce a hydrogen gas. Some nonmetals react with bases like sodium hydroxide, but no hydrogen gas is produced. Reactions of nonmetals with bases are complex. We will study them in higher classes. Reaction with salt solution, displacement reaction. More reactive metals displace less reactive metals from its salt solution. More reactive metals become a part of the salt solution, and less reactive metal is set free. Zinc is more reactive than iron, which is more reactive than copper. Metal displaces copper from copper sulfate. Zinc Zn metal plus copper sulfate CuSO4 blue color gives us zinc sulfate ZnSO4. Zinc displaces copper plus copper Cu red. When a strip of zinc metal is placed in a blue colored copper sulfate solution for some time, the blue color fades gradually. It becomes a colorless zinc sulfate solution, and red colored copper metal is disposed on the zinc strip. Potassium is most reactive, then sodium, then calcium, then magnesium, then aluminium, then zinc, then iron, then tin, then lead, then copper, then silver, then gold, then platinum. Zinc metal displaces copper metal from copper sulfate solution because zinc is more reactive than copper. Since copper is less reactive than zinc, If we place a strip of copper metal in zinc sulfate solution, then no displacement reaction occurs. Copper Cu, which is a metal, plus zinc sulfate ZnSO4 gives us no reaction. Iron metal displaces copper from copper sulfate. Iron Fe metal plus copper sulfate CuSO4 metal salt solution blue color gives us iron sulfate FeSO4 metal salt solution greenish color plus copper Cu, which is red. Zinc metal displaces iron from iron sulfate. Zinc Zn metal plus iron sulfate FeSO4 greenish gives us zinc sulfate ZnSO4 colorless plus iron Fe gray. Use the reactivity series to check if a metal displaces another metal from its salt solution. If we look at the reactivity table, magnesium metal is more reactive than zinc, iron, and copper. Hence, magnesium metal can displace zinc, iron, and copper metals from the salt solution. Magnesium metal displaces copper from copper sulfate solution because magnesium is more reactive than copper. Magnesium Mg metal. This copper sulfate solution, CuSO4, blue colored metal salt, gives us metal magnesium sulfate MgSO4 colorless metal salt plus Cu copper red. More reactive metal displaces the less reactive metal. Less reactive metal cannot displace a more reactive metal. Some nonmetals react with salt solutions of different nonmetals. Just like metals, more reactive nonmetals displace less reactive nonmetals from the salt solution. We will study this displacement reaction in higher classes. Just like physical properties, chemical properties can be used to distinguish metals and nonmetals. Uses of metals. Metals are widely used for different purposes. Table 4.2. Uses of metals. Copper, Cu. Being ductile, it is used for making electric wires. It is a good conductor of heat, so it is used to make base of cooking utensils. Aluminium, Al. It is being ductile and good conductor of electricity. It is used for making electric wires. Being malleable, it is used for making foils for packaging. It is a good conductor of heat, and so it is used for making utensils. Iron, Fe. It is strong and hard and so used for making iron sheets. Alloys of iron are used for making bridges and buildings. Mercury, Hd. Being shiny and good conductor of heat, it is used in thermometers. Gold and silver. Gold and silver are shiny, malleable, and least reactive metals, and so are used for making decorative jewelry and ornaments. Uses of nonmetals. Like metals, nonmetals are used in everyday life and industries. Important uses of common nonmetals are as follows. Table 4.3. Uses of nonmetals. Oxygen, O. It is required for respiration by all living organisms. It is essential for burning. Carbon, C. It is used. It is a major element in all components of our food like carbohydrates, proteins, and fats. A pure form of carbon called diamond is used for making jewelry. Carbon is a part of many compounds used in the manufacturing of textiles, dyes, plastics, papers and fuels. Hydrogen, S, H, most common nonmetal. It is part of ammonia, which is used to make fertilizer. It is used in hydrogenation of vegetable oils to make vegetable ghee. Liquid hydrogen is used as rocket fuel. Nitrogen, N2. It is used in manufacturing ammonia, which is used in fertilizers. Liquid nitrogen is used for freezing food and other things for very long. It is used as filling space to food packages like water packets. Sulfur, S. It is used to make chemicals, sulfur drugs, and antiseptic creams. It is used to make strong and tough rubber. Phosphorus, P. It is used for making firecrackers, smoke screens, and fertilizers. Chlorine, Cl. It is used for water purification process. Thank you.